Welcome to Malware Analysis for Hedgehogs. Today we will take a look at a ransomware again, and this one it's an older sample, and I chose this for several reasons. Firstly, I think the unpacking portion provides some new insights to you, so if you have seen all of the other unpacking videos, this might still be something new that you can learn from. And secondly, this I want to not only unpack this ransomware, I also want to look into the code to find the flaw in it and explain how this may enable us to write a decryptor for this ransomware, which is usually what you're interested in if you analyze ransomware. And for that reason, if I take a current sample and point out the flaw, that might be a hint to the malware authors how to fix their encryption, which is why I chose an older sample. And nevertheless, once you got the hang of it, you can apply those things to newer samples as well. So let's take a look at this one. And as I told you before, and maybe a dozen times, I usually look into the Hex Editor first, because this is really something the sample cannot really mess with. I mean, it's if you use any tool that parses the PE format, you can mess with the output by just having some weird stuff in there that makes the parser go nuts. But the Hex Editor usually it doesn't have so much problems parsing. It just needs to show you the bytes and bits in there. And whereas the PE format, if it's a PE file, is pretty complex, and saying it's showing you the correct things, it's almost impossible to do. Okay, so you have this view here for the first look. We see it's a PE file, of course. It's not so big, so you can scroll through it. And if you have smaller samples, I mean, malware is usually small, mostly, unless it's pumped or something. But usually the main portion of the malware is small. And in this case, although this sample. So now if you look at this here, string blow up whatever, this is hints to being a .NET assembly. So the .NET assembly has an interesting portion that you can find in the binary by searching for module here. So if you search for that, you get to the interesting part for .NET files. And the buildup is usually like this. You first have the code, which you can only read if you have a decompiler or a disassembly. Well, is it still called disassembly? I believe so. But if you get the not the decompiled code, but the intermediate language. And after that is the portion where the names of the classes and the methods are stored. So here you find, even if a decompiler is not able to read this because it's kind of messed up, you will still see what functions are used by this file. And we see this is called enco.exe. Okay. And we see, not so much interesting stuff so far. Something with decryption, encryption, yeah. Base 64 here, create decryptor. And these are, this portion is in ASCII. And after that is a portion or a block with strings that are white strings or Unicode strings. And those are reference strings in the code. So if you have a variable string 1 is equals load, and then load is the string that's being referenced. And that's especially interesting here, this part. Now these are usually functions, load and get bytes. A normal file would have these function not as a Unicode string in here. It would just plainly use the function, import it and use it. In this case, they reference a string and they use reflection to execute the function. So we would have some reference to reflection somewhere. Let's search everywhere. Yeah, here it is. So we see it's using reflection, and that's a common way for, if you have a packed file, that's usually the case, that you have some kind of assembly loading portion, and oftentimes it's put into a string, referenced as a string, and not used directly, because if you use it directly, tools might be able to, I think that this is the reason that tools might be easier get the idea that this is the portion where the assembly is being loaded. So let's see, what do we have here? There are also some weird strings in there, and if you look a bit down, it says something like inspector software HTTP analyzer standalone. Well, I doubt that. Like, who would make an HTTP analyzer, call it encoder.exe? I don't know. And then there's a part that is very dense, has high entropy, I believe. So this could be some encrypted stuff right here. So down there is the version information, and again it says HTTP analyzer standalone. So that's the version info. The other part I think was metadata of the .NET file, but it has the same data in this case. That's the import for a .NET file. The msquery.dll. Okay. Nice. So what do? We use decompiler, of course. Yeah, decompiler. I think you saw that too. I forgot to point it out. It's here, or also down below. Smart Assembly Memory Management. Now, here, powered by Smart Assembly 6.8. So you know this has been obfuscated, and we expect to see some code that's not so readable that easily. And let's use the nspy. I think that was a 32-bit file. And that only matters if you debug it, but okay. So no, that doesn't work. We have to set this to all files and alpha. Okay. And we can see it here. There's the entry point has some Unicode symbols, and it's kind of ugly. I mean, you could still go through this and, well, okay. But, you know, remembering the functions or variables this way is pretty much impossible, which is why I like to use d4dot for just cleaning this up a bit. So let's just drag this here in d4dot, and d4dot can deobfuscate Smart Assembly, so it's doing that. This is the heating, I believe. Those sounds. And now you get this cleaned file and see the difference. Cleat and IE inspector software. It's really so. And now it's it has weird names again, but it's kind of better. It calls them now method 0, method 1. It's a bit better than having these Unicode symbols. Yeah, and taking a look at that, you know, when you're at this main portion here, you can go to the entry point using this reference here. So that's how you get to the entry point. And now you can see, okay, it enables visual starts, it does something, set compatible rendering default forwards, and then run, and then it creates an instance of this one. So we would just click on that and get to the constructor of the class, and this constructor will do the rest. Bad practice. Like, the constructor shouldn't do a lot of stuff. But okay, who cares? It's malware. And the initialized component is the first one that's being called here. And then it sets an event handler. And the event handler is something that will be, well, the event handler, if a certain event happens, this event handler will do its thing. So we will check this out, this event handler. And there's other stuff going on, but here's an application exit. And before it exits, we have this method 0 and class 2 method 0. So there's at least 3 methods we should look into. Let's check the first one. And it's not doing much, just return a string. And then we have this one in class 2 0. And this is doing a bit more. It looks like unsafe, but it doesn't return anything, it just does something. So not so much interesting stuff. Let's go back. And if method 1 returns true, so let's check this one. Yeah, that's more interesting here. It seems to be the case that this always returns true. So it's actually, well, the interesting stuff happens here. And when I see this cluster of functions here, I prefer to go from the inner to the outer method calls. These are methods. So I would start with this one. So that's the first, the most inner call to method. So let's start with this one. And that's more interesting because it looks like it's invoking something. Now here's the reference to this load. We could have also just found this reference by using the search for strings, which is possible. But now we got here by just following the code. And so it says it uses reflection here to build up a method, right? So it says this is a method info, and the name is load, and get the parameters, whatever, and the parameter has this type, and then it invokes the load method. So this using this as parameter. So what this does is basically just an obfuscated way to say load this assembly that's referenced in these bytes here. So we are interested in the contents of this array. This should be probably some other another assembly that's being loaded into memory right here. And later, probably it will call this assembly. So we just put a breakpoint here using F9, and then we start the execution. We just put one here. Actually, it doesn't really matter. We just want this byte 0. And that should be it. Like, where was this called? I mean, where does this byte 0 stuff come from? I think that would be interesting too. It's here. It's class 2 struct 0. And this was... this method 0 was preparing this, I guess. Doing some decryption, I guess. So they prepared this static byte 0 in this struct byte 1. That's byte 1. And that's set here. Yeah, now we see where this comes from. Like, the byte array that they use to decrypt from is in the resources, and that's the name of this resource. We should be able to access it here. So, and then you can see if you save this. Oh no, you don't have to save this. I think you can also just say open the Hex Editor or something. Show an Hex Editor. Here it is, and you see it's encrypted. So this is being decrypted. Yeah, that's also the portion where I pointed out that might be some encrypted stuff. Yeah, okay, so we set our breakpoint, so let's just start. And we can use the clean one. Okay. And we are at the entry point, so we will just continue. And now we are here. And there's the byte 0 array where it says it contains more than 10,000 child items and it will be limited to displaying the number of items when expanded. That's okay. Yes, please expand it. And yeah, indeed, confirmation is now 4D5A, that's MZ. So we can just dump this part. See this in the memory. So we have indeed save. I think save selection. If you right click save selection, you can now dump this. Dumped P file. Okay. And take a look at it. So stop this from running and we open that up. Okay, bulwarker, and it's a DLL, so we cannot really execute this or debug this directly. We would have to use some other way to check. Basically, the problem with the DLL, of course, is it has no it has no direct entry point, so you cannot know by now where the code execution continues. We would have to see that by analyzing the encode.exe. So we find out what part of that DLL is actually called, and that's how we can go about it. So here's no entry point where we could know where to start from. But what we can do is just take a look through this and see what it might be doing. And it's quite some big library. So here are settings, so like anti-debugging, anti-disassembly, whatever, anti-AV stuff, and enable startup. So we already have the settings of this. It looks like this is part of maybe a crypter, and this portion of the crypto, this DLL, is loaded dynamically. So lots of people's kids, they basically just buy crypto software where they can click in all those things, and they are written to the settings portion here, and then the library would check which settings are enabled and which are not, and then do this. So we have no EOF data, okay. No enable startup, no enable fake, no elevation, and why is everything disabled? It's boring, but injection target is 4, okay. And there's this mutex being used. So if now seeing that, I would suspect it's used to inject something which we might want to get from the file. Interesting. So now the main file is this main class is bulwarker, whatever, and it does something. Okay, we can now see here that this is checking the encryption, the settings of, I guess these settings. It's doing the mutex stuff, it's doing the injection stuff, so yeah, enable startup, enable fake error, whatever. So at some point it must have read the settings into this local variable, and now that's the main portion where it checks the settings and then does what the settings are set to. So anti-virtual machine, anti-sandbox, like this are the anti-Wireshark. Let's check this. Is VM. Yeah, it's looking for, you see, it's looking for certain registry values, and if you have VirtualBox gas editions, the malware might not run. So that's also why a lot of people will recommend that you don't install them at all. I do that because I need them for the videos, so otherwise, yeah, but just for the video VM. So also VMware tools. So if this doesn't run, this might be a reason, but we know from the settings, I think it doesn't use any antis, right? Oh, it might use some. It might. I'm not sure. Yeah, but whatever. You know the reasons why this will... You could fix that if necessary. That's not the problem, because now we know what it's looking for. And usually you have two ways to fix that. You can fix the binary, or you can fix the registry values. Fix, I mean, you would destroy them basically, but usually if you don't restart, most of the time these values aren't necessary right at the moment where you analyze the file, so you can just do that temporarily, or just set back the machine, Okay. Where are we? So shield library, it's so much stuff here. It's kind of interesting just to go through the code, This is also creating an instance of this class, so I would like to look into that. And there are some interesting imports for usual Windows system DLLs. And what's that? Encrypt, XOR encrypt, decompress, resource manager file, assembly get object main, whatever. So it's getting file from the resources. Let's take a look at the resources again. There's file. Nice one. So take a look at this in the Hex Editor. And yeah, that's likely the stuff that they will inject later. So this is what we're interested in. We want to have this, but in the decrypted form. So I will not save it this way. Now you can go, there are several possibilities to go about this. You can just use the code, like save this resource and then copy the code that does the decryption on this part and write your own code with this copied decryption portion to dump this and decrypt and dump this and write this down to disk. So that's one possibility. And the other is just plainly debug it until it's in decrypted form in memory. And that's what we are going to do now. Yeah, that's what we will be doing now. Okay, let's start again this alpha cleaned. Right, we may just continue until we are here. Okay, that's where we got our library. And you can see down here, it's doing something, an invoke on get bytes. So it's calling a method called get bytes. Is there something else like that? Get bytes. What bytes does it get? I will set a breakpoint here too and just reload. Okay, continue. We are at this get bytes thingy, and it says get bytes for SHA-0 as a. Okay, that's something I would note down, like onto a notebook, an actual notebook. Like, this seems to be a function we are interested in, and the question is this a function of. Let me write this down here. No, I don't want to. Cancel. Stop this. Don't annoy me. Here. So it's WG for JJFL for Q. This is probably some variable name or something. What if we search for this one? I'm interested in what this actually is. How can I, let's just stop that. And searching was, how did that work again? For here, I guess this one. Searching, and we say search for, not for all files. What does it find though? It doesn't find anything. That's sad. I thought it might be something that's, it could be in the library, or it could be in the current file. That's my guess. All of the above number string. Let's take a look at this. And we get something. I see. And here we are. That's the text. And we are in... Where are we? Actually. Which file? It's part of encode.exe, ns1 here, and that's the, okay, that's where the text came from initially. And here it is again, and that's, why does it have this weird name though? I know, that's just the other one I loaded in here, which is a bit confusing. Let's remove that. Okay, whatever. I'm not sure what it does. Maybe we find out later. Or what's being used for. Search for all of the above. Let's take a look. No. Number string. Initialize. Yeah, it just finds it in here. Which isn't getting me any further. Okay. Let's just, I would just at this point just try to step a bit through the code instead of trying to find something. And That's okay. I will remove this breakpoint. This one. I think I did. Yeah. And continue. We get to this one. And we may just step over that and see where this starts loading up. I think at this point it's quite beneficial to have a process monitor running. So Explorer, I meant Process Explorer, because then you can see when if you got too far with debugging, you will see that this will do the injection part. So we have this open as well. Now, let's have this side by side, please. Yes. Okay. And now just step a bit through the stuff. And at this point, okay, continue. Now we are here. Now it should load this into memory. Loading it into memory is still not executing it. So it's just loading the assembly into memory. So let's step over. And now we are here. And this portion is returning some types. Okay. If I just go over this, we are still so you know, here it will return true and then it will exit. So this method should be the portion where it calls something from that DLL. So we will step into it. Return base text. Really? Step into. What is this doing? I'm a bit confused. We are now in some library of some .NET library. Maybe that just step out again. I am a bit confused. Ah yeah, okay. That's from the step into, we got into this .text, get text. That's not where we wanted to go into, but maybe we are now here at method 0. That's what we wanted to have, right? And there's method info invoke, type get methods. Ooh. I guess it will invoke some part of the DLL. I'm not sure which part. And it's invoking this? Okay, that's where the string is used. And that's the string 0. Yeah, you see. So it's probably... Well, it didn't find it in here, right? It didn't find the string. I would guess now that this is a method or something in this bulwarker. But I don't see this. Also, I searched for it and didn't find it with the search. So I'm not quite sure what it's doing there. And why it doesn't find it. Okay, so let's just step into until we get to the DLL. Maybe that will help. And now we are indeed in the system.net libraries, functions. But at some point we will have to get to the DLL. And you will know that you ran too far when you step too much. Return this to array. Is this actually doing what I want? Let's check this add runtime stuff. Can we step out and step out? Method info invoke. Oh, so we need to get into the invoke, I guess. Yeah, I think that's makes more sense. And check consistency. Okay. We get, where should we, here, that's the point where we want to get to, or this, where we have to step into that or that, and continue, go into signature, return this signature. That's good. Now we are in the DLL. I hope you kind of saw what I did there. The thing is, this invoke call is reflection, so it's using the libraries to call something from the DLL. And I just stepped into whenever there was this something invoke in the method name. So, and at some point you get to the DLL that's been used. So we can now debug the DLL here. And that's a good point to make a snapshot of your VM in case you mess up, so you don't have to go through all this again and again. I will do that now and make a snapshot in case I mess this up too. So, and now I'm back from creating the snapshot and ready to see what's being done here. We will step into this. It's an interesting portion because here's this decryption portion. So I would like to get to this point where the result is saved and maybe returned here. So that one. Let's continue. And we are there. Here's the results. Yes, that's a good sign that it's a lot. And here we have the 4D5A, which should be a sign to you that this is interesting, that you want to look at this and show that in the memory. Save the selection dumped PE2. Save. And I think we can stop this now. Yes. Did it stop? It did. And here's the second. And just, no, dragging in there doesn't work. So let's make this a bit more clean here. It's a bit annoying. Okay, we open the dumped PE2 and see if we got the payload or if there's still another. Well, it's called alpha. Great. And it's obfuscated with something. Put it into d4 dot. And it says it detected more than one obfuscator. You cannot choose which one you want to have there. But, well, it just chose the first one or something. And, but for now, I think it's a good idea to just have this. I mean, at least the names are not that weird anymore, and that's quite nice. And yeah, you see why I detected so many obfuscators. Like those are all obfuscators, like Goliath, Smart Assembly, something else. Babel is an obfuscator, I know. Confuser is maybe, yeah, whatever I'm not sure if those actually have been used or if it's just having these false signs that it so that the tools get messed up or whatever. But yeah, it looks like the stuff is readable, so why should we care? The automation did quite well here. So, and that's the ransomware, yeah. So it has an extension .encrypt. Nice one. I will leave that for the second part of looking into the payload of the ransomware, finding the flaw, and maybe creating a decryptor. So that's it for today. Thanks for watching, and I hope you learned something new.